Okay, supergroup Archaeplastida. So this includes the red algae, the chlorophytes, the charophytes, and the land plants. So again, in this chapter, we're only going to cover the first two here, the red algae and the chlorophytes. The charophytes here, which are land plants' closest non-plant relatives, okay, charophytes are protists. I'll cover that when we get to the plant chapter, okay? But notice this is what I was talking about earlier, where these, oh, wait a minute. I think I'm talking about that in a little bit, maybe not. I'll get to that in a minute. Okay. So starting with red algae. Most of them are multicellular, and they're found primarily in warm tropical waters. They get their red color from a pigment called phycoerythrin. You don't need to know that. But the red pigment, phycoerythrin, masks the green chlorophyll. So they have chlorophyll, but they have more of the red pigment. The deeper the organism is found, so the deeper the water, in other words, the redder it is. And that's because phycoerythrin, that pigment, allows those organisms to absorb green light and blue light, which, as it turns out, penetrates relatively far into the water. So it penetrates further into the water than red light. Okay, so that's why the red light is what's reflected. Okay, so you may have heard this, you know, like in the sense of like fire trucks, right? Why are fire trucks red? Fire trucks started to be painted a different color. I think it was Sholo Fire Department that had the, you know, bright yellow ones, because that's the first color that shows up and the last color to disappear as it gets light in the morning and as it gets dark in the evening. Red is one of the first colors that drops off when the light decreases. Okay. Red algae reproduce sexually, and alternation of generations is common in these organisms as well. So very similar to what we saw with the multicellular brown algae, the laminaria. So there's all different kinds of red algae. Here's an example of one. The bigger ones are informally known as seaweed, okay, the red seaweed. Some of them are edible. Okay, so if you enjoy sushi, the wrap around the sushi is made with nori, which is a type of red algae. Okay. So the next subgroup are the green algae. So yeah, this is what I wanted to bring up. Green algae is a paraphyletic group. Do you see how it says green algae here? And it also says green algae here, because it includes the common ancestor to all three of these groups, the chlorophytes, the charophytes, and the land plants. But green algae excludes the land plants. So when we talk about green algae, we're deliberately excluding land plants, and so that makes it a paraphyletic group. And that, you know, that kind of, you know, bothers some people because they don't want to see green algae on a phylogenetic tree, and I understand why. And there are some folks who advocate for reclassifying green algae into an expanded kingdom, so to where land plants would include chlorophytes and charophytes, so that it wouldn't be a green algae wouldn't be a paraphyletic group. Okay, so let's look at the, like I said, we're not going to cover charophytes today, but let's say a few words about chlorophytes. They're pretty they're pretty diverse. They can be single-celled, they can be single-celled but colonial, or they can be multicellular. You know, most of them occur in fresh water. Um, in fact, when students, you know, come across green things in their observations doing their field notebooks, they tend to call it moss. Moss is a plant, as we will see, but most of the time what they're looking at is green algae. Some single-celled species live in symbiosis with other eukaryotes. And so a great example of that symbiosis is what's seen in lichens. Okay, lichens is something else that students tend to want to call moss because it grows on tree bark and other places where moss does grow. Okay, ecologically, they're very similar. But there's something totally different. So a lichen is actually comprised of, it's got a fungus component and an algae component. Okay. Most green algae have complex life cycles with both sexual and asexual reproductive stages, even the single-celled ones. So it's pretty interesting group of organisms. And with respect to the evolution of size and complexity in this group of organisms, pretty much everything is represented. And so let me show you what I mean by that. So here's three examples that illustrate that. At the top, you have Zygnema, which forms colonies. So it's single-celled, but it forms colonies. Ulva, the sea lettuce, is a true multicellular organism. And then finally, this one is really weird, this Colerpa here, this frond-like organism. I mean, you look at this and you're like, well, that's big. It's got to be multicellular. But in fact, it isn't. It's an organism that consists of one giant cell with hundreds and hundreds of nuclei. And that comes about thanks to repeated mitosis without cytokinesis. Okay, so now you understand the reason for there having to be two separate terms, right, for nuclear division and division of the cytoplasm, because in a lot of organisms you can have nuclear division, multiple nuclei, but no cytokinesis. It's still one big cell, functions as one big cell. Questions on this? Oh, forgot to talk about this. This is the fun slide. This is the fun fact. Chlorophytes include the unicellular green algae in the genus Chlamydomonas. One species in this genus, Chlamydomonas nivalis, is one of several species that lives in snow. And it makes the snow pink. The best time of year to see pink snow is in the summertime, because that's when they really crank up the production of red pigment. These are carotenoid type pigments. And carotenoids, if you'll remember from the chapter on photosynthesis, are photoprotective. UV light is very, very damaging. And so you have these little dormant zygotes of algae, and the carotenoid pigments is there to protect that zygote from UV radiation. And summertime is when UV radiation is the strongest. So if you have to go to high elevation where the snow doesn't melt, okay, so probably not in Arizona. I've seen this more, you know, in Northern California, Wyoming, and places like that, to see this pink snow. So these algae also have chlorophyll as well, but it's the carotenoids that are really dominant. Okay, and that does it for the supergroup Archaeplastida. Questions?